Next part, we take the refraction of light. So you can see here that you have air as one medium and you have water as the second medium. So in between, I'm calling it as the boundary, separating the two media. So you have air, you have water. Now you should know that light travels faster in air than in water. So here the speed is higher, is high simply. Here the speed is low. I'm talking about the speed of light. So in air, light travels faster than in water. Similarly, air travels fast. In air, light travels faster than in glass. So here, air, light travels faster. Water, the speed is low. So this one, we say that air is less dense medium. Why we say that air is less dense? Because the molecules are far apart. It is a gas. So the molecules are far apart. So air is less dense. Then you have water, which is a denser medium. Okay, because in water, you know, the molecules are closer together. So you have air, less dense medium. You have glass, a denser medium. You should know that in air, light travels faster than in water. Now, I have a ray of light incident on the boundary here. The light is traveling from air and it is incident on the surface of water. Firstly, this is called the incident ray because according to the direction, the light is coming from air to water. So this is incident on the boundary. It is called the incident ray. This dotted line is called the normal. Why we draw a normal in dotted line? Because this line is imaginary. So that's why we draw it in dotted line. Now this is called the incident angle I. Be careful, the incident ray and the normal is here. The angle between these two is the incident angle. This one is not the incident angle because the angle is measured always from the incident ray and the normal. So it should be between the normal and the incident ray. So this is called the incident angle. Now, the ray was supposed to go straight like this if there was no change in the medium. Now, because the medium is changing, you have from air to water, there will be refraction. You know that what is refraction? It is the bending of the ray of light when it passes from one optical medium to another of different densities. So, why we say optical medium, it should be transparent so that light can pass through. Now, from one optical medium to another of different densities, the density should be different. As we say here, air is less dense, water is denser. Now, when light passes from a less dense to a denser medium, this is called the refracted ray. Okay, this is the refracted ray. We say that the refracted ray is bent towards the normal because if the medium were the same, the ray would have been going straight like this. Since there is a change in the medium having different density, now there will be refraction. And the refracted ray here, it is bent towards, it is coming towards because this is a normal starting from there up to here. This is the normal. So the refracted ray is bent towards. It was going straight, but since there is a change in medium of different density, the refracted ray is bent towards the normal. And this is the angle of refraction or the refracted angle. Again, the refracted angle is the angle between the refracted ray and the normal. Always the normal is concerned. Okay, so incident angle, refracted angle, incident ray, refracted ray, and you have the normal here. Now, you should remember that when light passes from a less dense medium to a denser medium, like here from air to water, from a less dense medium to a denser medium, the refracted ray is bent towards the normal. And you can see here that the angle of refraction is less than the angle of incidence because you can see the angle becoming smaller than the other one. So R is less than I. So this is refraction from a less dense to a denser medium. Now, if I change the medium, for example, I have air here. I'm removing air from here. Okay. I'll do the reverse now. I have the boundary. Let's say I'm taking glass here. And I have air here. This is the boundary. Now, you should be knowing which one will be the less dense and which one the denser medium. So air, molecules far apart, so less dense medium. And also that light travels faster in air. Then you have glass. Glass is a solid. The atoms, the molecules are closely packed together. So it will be denser medium. And here, light travels faster. Here, light travels slower because it is the denser medium. So less dense, denser medium. I draw an incident ray in this direction now. I'm drawing the incident ray in the denser medium, and the light will pass from the denser to the less dense medium. Again, this is the incident ray. This is the incident angle. This is the normal. Now, I'm drawing the refracted ray. Now, the ray was supposed to be going like this, straight, but since there is a change in media of different density, now the refracted ray will be bent from its original path. Now, because it is from denser to less dense, the refracted ray is bent away from the normal. When it was from less dense to denser, the refracted ray was bent towards the normal. Now it is from denser to less dense medium. So when it is from denser to less dense medium, the refracted ray is bent away from the normal. So here you have the normal. It was supposed to be the straight path going, the ray. But since there is a change in density in media, then the refracted ray goes away from the normal because it is from denser to less dense. So you have to remember, less dense to denser medium, refracted ray is bent towards the normal. When it is from denser to less dense medium, the refracted ray is bent away from the normal. And this is the refracted angle. And again, between normal and refracted ray, we call it the refracted angle. Incident ray is a normal, we call it the incident angle. And here you can see the refracted ray is the refracted angle is greater than the incident angle. So this is about refraction from a less dense to a denser medium and from a denser to a less dense medium. Now, you should be able also to draw rays when light passes through a glass block. So I'm drawing this rectangle representing the glass block. Okay, this is the glass block. I'll be having an incident ray here. So this is glass, this is air. So this one is less dense medium, and the glass here is the denser medium. Now, this is an incident ray. I write here, incident ray. I draw the normal here. This is the incident angle. Now, this ray coming from air entering glass, it is from a less dense to a denser medium. So, the refracted ray will be bent towards the normal. So you can see this is a normal, the ray not going straight but bent towards the normal because it is from less dense to denser medium. This is the refracted angle. Now when you draw the ray, it starts here up to here, the edge or the other side, the opposite side of the glass block. Now I will draw another normal here. And this one also will be angle R. Why it is R? This forms a Z angle. Here it is R, here as well it will be R. It forms a Z. Now, air to glass refracted ray bend towards the normal. Now, this ray will continue its path. After passing through the glass block, it will move out. It will emerge from the glass block. Now, here is a ray. Now, the ray will pass from glass to air, that is from dense to less dense medium. So when you draw it now, it should be something like this. So it was coming in this direction. Since it is from dense to less dense medium, it is bent away from the normal. So this angle will be called E, because this ray is called the emergent ray, and E is called the emergent angle. Now, what you have to remember here, when you draw the incident ray and the emergent ray, these two rays should be parallel. That is, this moving in this direction, this as well moving in the same direction. Okay, so you can see the incident ray and the emergent ray parallel to each other. They are moving in the same direction, so that's why they should be parallel. This one is called the refracted ray. So you can see here you have the incident ray, the refracted ray, and the emergent ray. These two should be parallel, and all rays of light should be having an arrow head. Without these arrows, they are not called rays of light. Now, if the incident ray is incident normally on the glass block, for example, I have a ray of light coming like this. As we say, this is called the incident ray. This is making 90 degrees perpendicular to the glass surface. Again, you have air to glass, but the incident ray is perpendicular to the glass surface. Now, when it is perpendicular to the glass surface, the normal also is found here on the incident ray and normal on the same line. The angle of incidence will be 0. Be careful with this. The angle of incidence is not 90 degrees. The angle of incidence is 0 degrees, because incident angle is taken from the incident ray and the normal. But now here, the incident ray and the normal lies on the same line. If they lie on the same line, there will be no angle. So the angle of incidence is 0 degree. Now, when the angle of incidence is 0, there will be no refraction. So the ray of light passes straight through the glass block. Here also 90 degrees. So you have the incident, you have no refraction, it continues like this, it emerges here, and you will be having 90 degrees. So remember, when you have a ray of light incident on a glass block at 90 degrees, the angle of incidence is 0, there is no refraction, the ray passes straight through the glass block.